Hi scholars! Welcome back to another thrilling adventure into the universe of math. Today, we're delving into a crucial concept, which is all about solving systems of equations. But first, what is a system of equations? Well, it's simply a set of two or more equations that we solve together because they all share the same variables. Let's start with systems of linear equations and two variables. These are equations that can be graphed as straight lines. For instance, we might have a system like this. Y equals 2x plus 1 and y equals negative x plus 3. We can solve this system by graphing, substitution, or elimination. First up, substitution. This method involves replacing one variable with an equivalent expression from another equation. We have y equals 2x plus 1 and y equals negative x plus 3. Since y equals both 2x plus 1 and negative x plus 3, we can set these two expressions equal to each other, like so, 2x plus 1 equals negative x plus 3. Then, we rearrange to get all the x terms on one side and the constant terms on the other, 2x plus x equals 3 minus 1, simplifying to 3x equals 2. Finally, divide by 3 on both sides to solve for x, we get x equals 2/3. Substitute x equals 2/3 into the first equation, y equals 2x plus 1, we get y equals 2 times 2/3 plus 1 equals 5/3. So, our solution is 2/3 and 5/3. Next, let's look at the elimination method. This involves adding or subtracting the equations in order to eliminate one of the variables. Our system is still the same. If we subtract the second equation from the first one, we get 0 equals 3x minus 2. Then, we add 2 to both sides and get 3x equals 2. Dividing by 3 on both sides, we find x equals 2/3, the same solution we got before. Substitute x equals 2/3 into the first equation again, we get y equals 2 times 2/3 plus 1 is equal to 5/3. So, the solution to the system is again 2/3 and 5/3. Systems of linear equations are everywhere in real life. They can help us find the best phone plan, determine the intersection of two roads, or even figure out how to score the best deal at a store. Now, let's kick it up a notch and discuss how to solve systems that involve a quadratic equation. These are systems that have at least one equation which is in a straight line when graphed. For example, let's solve the system y equals x squared and y equals 2x. We can solve this system graphically by plotting the parabola and the straight line and finding their points of intersection, or algebraically by setting the two equations equal to each other and solving for x and y. First, let's graph these equations. The first equation, y equals x squared, is a parabola that opens upward, while the second equation, y equals 2x, is a straight line with a slope of 2. The points where the line and parabola intersect are the solutions to our system. As you can see, the points of intersection are at 0, 0 and 2, 4. So, our solutions are x equals 0, y equals 0 and x equals 2, y equals 4. Now, let's also solve this system algebraically. Since both equations are set equal to y, we can set them equal to each other, x squared equals 2x. To solve this equation, we'll first move everything to one side to set it equal to 0. Subtract 2x from both sides to get x squared minus 2x equals 0. Now, factor out an x to get x times x minus 2 is equal to 0. Setting each factor equal to 0 gives us x equals 0 and x equals 2, the same x values we found graphically. Finally, substitute these values into the original equations to solve for y. When x equals 0, y equals 0, and when x equals 2, y equals 4. So, our solutions are again 0, 0 and 2, 4. And there you have it, folks. Whether you're dealing with systems of linear equations, quadratic systems, you now have the tools to tackle them all. That wraps up today's session on solving systems of equations. Remember, keep practicing and don't be afraid to get hands-on with real-world problems. Until next time, Keep crunching those numbers and stay curious.